All right, today we are going way, way out to the absolute edge of our solar system. We're heading to a place we've never actually seen, but we know it's there because it solves one of the biggest puzzles in astronomy. We are talking about the mysterious Oort Cloud. So let's get into it. So think about this for a second. We've got comets, right? These big, icy, dirty snowballs. Every time they swing past the sun, they burn up a little bit. Their orbits are pretty wild, kind of unstable. So you have to wonder, after 4.5 billion years, shouldn't they all be gone by now? Either burned out or flung out into space? And yet, we keep seeing new ones. So what's going on? To figure this out, we kind of have to put on our detective hats. Okay, so that brings us right to section 1, the comet paradox. Because before you can find the solution, you've got to really wrap your head around the problem. So to get this paradox, you first need to know that there are basically two different flavors of comets. You've got your short-period comets. These guys whip around the sun in less than 200 years. They're pretty predictable. They come from a big disk of icy stuff out past Neptune called the Kuiper Belt, and they stick to the same flat plane as all the planets. Easy enough. But then you have the long-period comets. Their journeys take thousands, sometimes millions of years. And here's the weird part. They don't follow the rules. They come at us from everywhere. Up, down, left, right, from every direction in the sky. And yeah, this is the group that's causing all the trouble. Okay, so here's the deal with these long-period comets. They have two massive problems that should make them super, super rare. For one, their orbits are just enormous and unstable. The gravity from our own giant planets, or even a star just passing by, should have kicked them out of the solar system or sent them crashing into the sun ages ago. And two, every single time they visit the inner solar system, the sun cooks them a little more, boiling off their ice and gas. They can only make that trip so many times before they fizzle out. So the question remains, where are all these fresh, new comets coming from? You know, this puzzle really had astronomers scratching their heads for decades. And then one guy came along with an idea that was, it was pretty out there. And here's our detective, the Dutch astronomer Jan Oort. Back in 1950, he was sifting through all the data on these weird, long-period comets. And just like a great investigator, he saw something, a pattern, a clue that nobody else had noticed. And this was his big aha moment. When Oort mapped out just how far these comets were traveling from the sun, he looked at their farthest point, the very top of their orbit. He found they weren't just turning around at random distances. Nope. They were all clustering around this one incredible distance, 20,000 astronomical units. That's 20,000 times farther from the sun than Earth is. That just can't be a coincidence, right? It had to mean they were all coming from the same place. So working with that one clue, Oort came up with this absolutely wild solution. He basically said, what if our entire solar system is encased in a giant spherical shell? A shell made of trillions of icy bodies, just sitting out there in a cosmic deep freeze, super far from the sun. This massive reservoir, which we now call the Oort Cloud, is like a storage facility for comets, keeping them safe since the solar system was born. And every now and then, it sends one our way. Okay, so if this thing is real, just how big are we talking? Well, get ready, because your idea of how big the solar system is about to be completely shattered. All right, let's start this journey right here at home in the inner solar system. This is the part we all recognize, right? The sun, the rocky planets, the asteroid belt, nice and familiar. Okay, now we're pulling back. We're flying past the gas giants like Jupiter and Saturn, all the way out past Neptune. And right beyond that, you've got the Kuiper Belt. That's where those short-period comets live. And this already feels impossibly far away, doesn't it? But just watch this. We're going to keep zooming out, and look. Our entire planetary system, everything we've seen so far, just shrinks down to a tiny little speck. We are now just reaching the inner boundary of the Oort Cloud. The sheer scale is it's hard to even process. This map here helps a little bit. It's a logarithmic scale, which is the only way to even fit this on a screen. Just look how tiny the planets are in comparison. The Oort Cloud is so huge that it reaches almost halfway to the next star system. This isn't just some outer region. This is the real edge of our solar system. This is where the sun's gravity finally starts to lose the battle against the pull of the rest of the galaxy. And this cloud isn't just one big, simple thing. Scientists think it actually has two main parts. First, there's a thicker, more disc-shaped inner part called the Hills cloud. Think of that as the main, stable reservoir. And then, beyond that, you have the massive, perfectly spherical outer cloud.
This is where those icy bodies are just barely hanging on to the sun's gravity. And it's from this outer sphere that our long-period comets get knocked loose.
So you might be wondering, how much stuff is actually in this cloud? Well, even with maybe trillions of these icy objects floating around, scientists estimate the total mass is only about 5 times the mass of the Earth. So it's not dense at all. It's just an enormous, ghostly sphere of ancient material.
Okay, but wait. If all these comets are just chilling out there, orbiting peacefully at the edge of everything, what knocks them off their path and sends them screaming towards the sun?
Well, it turns out all it takes is a tiny little cosmic nudge. An object can orbit out there for billions of years, perfectly stable. But because it's so far out, so weakly connected to the sun, the slightest little gravitational tug can change everything. Maybe a star passes relatively nearby, or maybe it's just the gentle tidal pull of our whole galaxy. That's all it takes to knock a comet out of its comfortable orbit and send it on a brand new journey, a long fall toward the inner solar system that can take millions of years.
And this, for me, is the most mind-blowing part of this whole story. For all we know about it, for how huge and important it is, the Oort cloud is still completely 100% unseen. I'm serious. We have never directly seen the largest structure in our own solar system. We can't. The objects in it are way too small, way too dark, and just unbelievably far away. The Oort cloud is still just a theory. A really, really good theory, but a theory nonetheless. Its entire existence is implied by the clues it sends us, those long-period comments. It's like a ghost we only know is there because we see its footprints. But we do have one little emissary from humanity, one lonely probe heading out into that vast darkness. That's Voyager 1. Launched way back in 1977, it's the farthest thing we've ever sent from home. And after all these years, it's now sailing through interstellar space on a path that will, one day, take it right through the Oort cloud.
But the timescales here, they're just hard to wrap your head around. It's going to take another 300 years just for Voyager 1 to reach the inner edge of the Oort cloud. And then it will take another 30,000 years to cross it and come out the other side. That journey alone just shows you the insane, mind-boggling scale of this invisible bubble that surrounds our solar system. So, all of this leaves us with one final, fascinating question. We believe the Oort cloud is made of pristine stuff, leftover material from the birth of our planets 4.5 billion years ago. We know it sends us comets, but what else is hiding out there? What other secrets, what other frozen relics from the dawn of our solar system are still silently circling at the edge of everything, waiting in the dark?